Today we're starting with these types of problems again because we're going to be coming back to our factoring idea that we were taking a look at, I think it was last week. But we're going to be doing problems that are a little bit more difficult this time around. So kind of starting again with a refresher. And this also follows up on the heels of the work we did yesterday with our exponent rules, because we're going to be using those as we go through. So I'm going to be just distributing this 5x to the fourth to each term that is inside the parentheses. So we're going to the first term first. So I'm going to do the 5 times the 7, which gives me 35. And then x to the fourth times x to the 6th. Remember, we add the exponents. So that becomes x to the 10th. That just comes out of that work that we did yesterday right there. Then I'm going to multiply the same 5x to the fourth out to the 16x. The plus stays a plus. 5 times 16 is going to be 80. And so that becomes 80x to the power of 5, remember. Because yes, there is a power of 1 on that x, even though we didn't write it in, that is x to the power of 1. And then finally we do the same thing multiplying to the 2, the minus stays a minus there. And then I multiply by 2, which affects the 5, but does not affect the x because there's no x in the 2. And so then this is our final simplified answer. When you see that word simplify, basically get rid of those parentheses. All right, we're going to repeat the same thing with the last problem as well. So go ahead and just distribute that number in. So we end up with 24, oops, it all of a sudden doesn't want to write, 24x to the 7th minus 22x to the 5th minus 8x cubed. And so yes, we are taking that same kind of methodology and applying it to factoring today. Go ahead and write down this problem, and we'll take a look at how we would approach it. Now, based on the work that we did before with this type of factoring, we would look at the 18, the 9, and the 21, and we'd say, what can I divide all three of those by? And in this case, looks like a 3. And that looks like it's about it. And so then, if that's all we did, then we'd end up with this. 3 times 6x to the 8th plus 3x to the 5th plus 7x squared. And that's what we did last time. That's what we did last week. But if you're really keen on this, you're probably noticing there's something else inside of those parentheses that's in every single term. Notice in all of these, they include some x's. So we're also going to be able to pull out some x's from every term. Now the question is, how many x's can I pull out of every term? Well, notice I have 8 in the first term, 5 in the second term, and 2 in the last term. So that means I must be able to pull 2 out of every single term. And so that's what we're going to do here, is instead of just pulling out a 3, we're going to pull out a 3x squared. And so if we do that now, so now we're just pulling out those x's. So I'm not affecting the numbers, so the 6 is still a 6. So I have x to the 8th, and I'm taking out x squared. This is like division. Again, like the kind of problems we were doing yesterday. Remember, when I divide the variables, that means subtract the exponents. And so 8 minus 2 means that this is going to be 6x to the 6th. Plus 3x to the power of, now I do the 5 minus the 2 that I'm pulling out of every term, which is going to leave me with a 3 there. And then plus the 7, and if I pull x squared out of x squared, it cancels itself out. So all that's left is the 7. And so we're done. This would be the fully factored form. And in case you're wondering, did we have to go through this in order to get there? No. If you want to, you can go straight from the original to that line. If you see which number we pull out of every term and how many x's we pull out of every term, you can go straight there. That's no problem. Now, just take a look at this problem. It's the same basic process. We're going to be looking at every single term and just saying, what can I pull out of every term? And I first look at the numbers. So the 8, the 12, and the 15. What can I divide all of those by? 1. That's about it. There is no number other than 1 that I could divide out of all 3 of those. So there's no number that I'm going to factor out this time. But there are x's in every term, so we're going to be able to factor out some x's. Now, in the last one, I factored out x squared because 2 was the minimum number of x's in a term. do the same kind of thing here. Look for the minimum number of x's. In this case, that is the x to the fourth. So that's what I'm going to factor out. I'm going to pull x to the fourth outside of my parentheses. And now I'm basically going through and dividing each of those terms by that x to the fourth. So 8x to the sixth becomes 8x squared. Remember, I'm doing the 6th power that I started with, and I'm subtracting the 4 that I'm dividing out. All right, minus 12. 5 minus 4 would give me a 1, so it's x to the 1, but of course we don't need to write x to the power of 1, right? That's just x. And then plus the 15, and if I take out all of the x to the fourth, it's just the 15 that's left behind. And so then this is our final answer. So as you take a look at this one, again, we're doing the same kind of factoring process. And I start by looking at the numbers and I see what can I divide them all by. And in this case, yes, I can divide them all out, but in this case, by 3, right? But we're going to see something interesting that comes up along the way here. So if I factor out the 3, I'm going to end up with a negative 2x to the 7th plus 8x to the 5th minus 3. But the tricky thing with this one is that I now start with that negative 2. That's kind of awkward. We don't really want to do that. And so what I want to do then is I'm actually going to change that 3. Instead of factoring out 3, I'm going to factor out a negative 3. When we factor out, it's sometimes required, sometimes not, to pull out that negative, but it's always good form to start with a positive number inside of your parentheses. So then, in order to do that, I'll go ahead and do it as a separate line, the next line, but I could actually go back and just erase off of that. So if I factored out a negative 3 instead, that negative basically is flipping the signs of everything inside. So it becomes a positive 2x to the 7th, it becomes a minus 8x to the 5th, and it becomes a plus 3. So it's like I took all the terms and divided by negative 3. Now in this problem, you'll notice though also there were no x's in this last term, hence why there's no x's out front here. All right, and so for this last one, we want to look at every single term and see what I can pull out of every single term. So I'm going to start by taking a look at the numbers. So 66, 99, and 44. What can I divide them all by? 11, absolutely. So we're going to divide everything out by 11. So we know that part. Now, is it going to be a positive 11 or a negative 11? Positive, yes, because it's a positive 66 at the start. We always want to start with a positive there. All right, then I take a look at my x's. I have x to the 9th, x cubed, and x to the 8th. How many x's can I pull out of every term? 3. This one was kind of tricky because usually the smallest one is going to be the last one. But it's not in this case. In this particular case, the smallest one happens to have been put into the middle. Basically, just because I'm trying to keep you on your toes. All right, so then I'm going to pull out 11x cubed. And yes, you could do this in 2 separate lines, or you can do it all in one line. All right, so that's going to give me 6x to the 6th plus 9 minus 4x to the 5th. And that's it. That's done.